Our next topic is to talk about log in and log out. Now, just in general, I have this GitHub repository called DJ for eSamples, and every once in a while you ought to see if I've found some bugs and fixed them. So go over to your samples and do a git pull. So every once in a while, just do that. So Django, like in lots of situations, comes with a built-in log-in, log-out system. There's lots of ways to do it. You can read up on it. It has a way to create users, has this nice admin interface, and so one of the things we like about Django is that we don't have to build some of these basic maintenance things. It has permissions and groups. We use this in the local library application, but we're not going to use that so much in our applications. And passwords, etc. And it has a way to store these things in various techniques. And so the first thing that you'll probably encounter when you're doing this is to create a super user. And so you have to log into your system, you create a super user, give it a name, an email address. The email address is for password recovery, even though you can log in and you can change your super user password anywhere. And then you do it. Now there's a great XKCD cartoon for so many things. This is, one guy says, make me a sandwich, and the other one says, what? Make it yourself? And then says, sudo, make me a sandwich. And the other person says, okay. So what sudo means is it's a Linux command to switch to the super user and do a command. So if you don't have permissions to do a command, you can say sudo a command. And so that's what this XKCD. So that's what we call a super user. That's the user that has all permissions, doesn't need to get any special permissions. This might be a good time to review what you're going to do when you wipe out your database. When you create that super user, it just adds a row into a table in your DB SQLite, and you can wipe this out anytime. That's why I like using SQLite for development in Django. If you remove it, you've removed all the tables, all of the tables created by migrations. The migrate command is what creates tables. The make migration actually creates migrations with your Python code. So if you're going to start fresh, you got to remove the DB SQLite file. That's got rid of all your users, all your super users, any data you've put in, it's gone. And then you have to wake it back up with a bunch of empty tables with a manage.py migrate, and you'll see all those things. Lots of lines come out at that point. I didn't include them. And then you're going to have to create your super users again. So just if you wipe your database, you got to recreate your super users. Once you have a super user, the rest of the users are put in using the admin interface. You just go in and among all the other models that you might have in your application, the groups and the users are just models. They're models that happen to be built into Django, and you don't have any responsibility for building them. And so, like I said, the groups and permissions is useful, and you can read up on that, and maybe your application needs to use those. But for me, I pretty much just make users and call it good. Later, we're going to learn how to use like social login. So we'll use GitHub to log people in, so you don't have to create any users other than your admin user. But so now we're going to take a look at what we do with Django to handle logging users into and out of our application. So we talked about sessions recently, and making a session is not the same as being logged in. Logging in actually changes data in the session. Logging in general, the most basic way of logging in depends on the existence of a session, and logging in is putting data into the session about the current user and their name and their email, and then logging out is removing it. In the session, you could have multiple users. Log in with one user, log out. Log in with a different user, log out. If you're just in the same browser, you're going to end up with the same session just associated with different users. So remember, sessions and login are not the same thing. Just like cookies and sessions are not the same thing, sessions and login are not the same thing. But they all build on each other. Sessions build on cookies, and login builds on sessions. So to make this all work, you have to add to your installed apps all the Django support for all this login and logout stuff. Now, if you automatically built your project and you got a settings.py that they're going to just put this in automatically. So this is just so you know when you're looking at it where it is that all this magic functionality comes from. It comes from this installed apps. Also, for the login and logout, you're going to have to add a path to your project-wide. So DJ for eSamples, DJ for eSamples urls.py. This is not in any of your applications. This is in your Django project, and you add a path, and there's a bunch of URLs, and that gets all registered, and a whole bunch of wonderful magic happens at that point. And so that's how these URLs are activated in your Django project. so the applications. So the way we get the URLs to the login and logout features is we use the reverse. We've been using reverse all along. Reverse is the way we look up for a particular view. And in some URLs.py, matter of fact, in that Django contrib auth URLs, in that there is a name equals. And so there's a view in there that they've got that we didn't write, and it has a name equals, and it has name equals login and a name equals logout. And so we can do a reverse lookup like we would of any of our views that we might have. Say, give me the URL in this Django project for the view named login or the view named logout. And it's pretty simple. You could even probably hard code these, but maybe the route isn't exactly account slash, right? And so maybe you called them something else. And so that's why we use the reverse to look these things up. And so that's just a convenient way of doing it. Now, one of the things about logging in is sometimes you have an application and there's like a login button. But sometimes you just have pages that are protected by login. And then when you go to a page, it says, oh wait, you got to log in first. And then after you log in, you'll notice it typically just takes you right back to the page that you wanted to see. So you might bookmark a page when you're logged in, and then you log out, and then you click on that bookmark page, but that requires that you be logged in. So you're going to go to the page, and then when you're done logging in, you want to come right back to that page. And so that's using redirecting, but it's redirecting after login is successful or after logout is successful. Logouts are almost always successful. And so there's a parameter that we can add, a get parameter that we can add, and it's the next equals, and what we do is we give it a path. And so here's a little bit of code that we're going to play with in my sample codes under the authz project, under the authz application. And so I got a bunch of views, and I'm going to give them some names so that we can play with them. So these are just the urls.py. So if you take a look in this main.html template, you see a whole bunch of things. You see this next feature in action. So here's a couple things we can do. So there is this user object that in a sense is passed in. You don't have to do anything to pass it in. There's this user object that sits there in your template context that's automatically. We'll talk later about how you can sort of inject into every template certain little things that you got to inject. But the system injects this user. There is an attribute called isAuthenticated, which is true or false, to say whether you're not logged in or are logged in. And so if we see it, we say, oh, what's their person's full name, user.email, user.id. This user ID is the primary key. We might actually have later we'll have a foreign key that goes into the user table, and we need to know what the primary key of the current user is so we can populate our foreign key. So when we have a row and it's owned by such and so, we're going to actually put a foreign key into a table that we didn't even create. But the thing I'm talking about now is you can get a URL, that URL tag, that's looking up a name of a view. Log out is the name of a view. Log in is the name of a view. And then we have this question mark next equals. That's the parameter to say when you're all done with that login or log out, go back to this particular URL. Okay? And so that says go to the URL that's in the authz application, the view named open. And so that's one way of doing it. Another way, let's say in login, we're going to get the login URL and send ourselves back to the request path. The request is another one of these things that's dropped in automatically for us. That is the current URL of the view we're at. So in a sense, this is a contraction that says go ahead and go to login, and when you're back, come right back here. So login will log in and then redirect back to this page that we're on, whatever the page is, because this is going to be, this little main.html is used in a couple of my different views. So request.path is like come back here. So that's a good pattern to know, to just say log in and come back to this current path when you're all done. And so here's just a bunch of connections to this thing, and we have here's just all my links, and I have a couple of things. I have some no login required pages just to play around, and then I have one that's protected by hand in Python, and then one's required by a login mixin, and then I sort of dump all that data, and I think I showed you that one already. So here is one of them, right? I showed that. That's what this all looks like. You can see that these links have the next in there. You can This is how it turns out to be. You get accounts login. Oops, come back. You go to accounts login, next equals auth z open, and that's basically, I'm in this file right now, I'm in that URL, and that says go ahead and log me in, and then come back to this URL, to the auth z open. Here's an example of the logout URL with a next setup in it. And so the login page is something that's provided by Django, but it needs a template. And so what happens is we get to control the template. And we're going to go to this URL, the code behind the views, the code that looks up the password, the code that gives you errors. That's all taken care of. All the views are taken care of. And what we get to do is we get to describe a template that controls our look and feel. And so we can have a simple login thing or a pretty login thing, and we can have links to the rest of our application. And so we want control over our login page so it looks like it comes from our application rather than having it look like it came from Django. So I'm not going to go through in much detail about how this works. You have to create a template that can be accessed as registration/login.html. And remember that no matter which application in a Django project you're working in, those names are global. So for example, this name right here, registration login.html, the fact that it's in my home application doesn't matter. And that's why we have this extra slash in here. So just because it's in the home application doesn't mean it has to be, the home and the registration don't have to be the same in this particular case. And so this is a template that if they just do a render, so in their view, in the login view that's somewhere deep in Django, they're just going to do a render to registration/login.html. You have this somewhere in some application because the templates are global. It's going to find your template and put that in. So within this template, there's a few rules that you've got to follow. They're going to send some errors, and there's errors. If the form has errors, you have to have some output that deals with that. If next, that's actually that next equals parameter. Okay, and so if the next is there, and you've come into this log, and this one's a little bit weird. If you have a going forward page, that means you came from a page and you're going to go back to a page. If the authentication happens, that means you've been logged in, you went to the page kicked you back because it's protected by more than just logged in user. Okay, so this little bit right here, this is a little bit subtle. If you're not logged in, that's kind of the normal case. Please log in to see the site. And then we basically create a simple form. We're going to post to the login URL. That just looks up the login URL. And we've got this context variable called form, and we can print that out. That form has the key, that form has all of the input stuff in it. We're going to talk about forms coming up soon. And so that's what generates this form here. Generates all this stuff right here. And so there could be a bunch of things in there, but the form is a variable created by the view that has all the input names and areas, etc., that it wants. So we didn't have to actually construct the form. We do have to submit, put the login button, we could put a cancel button, and we do have to pass the next back as a hidden field. Now a hidden form field is just like a text field, except that it doesn't show up here. And so that's in there, and if you were to view source, you would see that. And so that's after you submit this form, it needs to know where we're going to go next. So then if you're successfully logged in, it's going to log you in, say yay, and then it's going to redirect to whatever that next value is. And that's our way of, it's going to give us the next value inside this template, but we have to give it back to the view when we post back into the view. So like I mentioned, there's a whole bunch of data that we can get. There is this user variable. And that user variable has their full name, their email, and very importantly, the primary key of the logged in user. But these things are only defined if user is authenticated is true. You can access this user data in Python. It's in a little different spot. It's in the request. So I just changed the name of request to REQ. That's just a variable name you pick. I will generally always write it as request or REQ. And so the user information that is pretty much the same as what's in the template tag, template context user. User is authenticated. Their username, their email. I could have had rec.user.id if I wanted here. and otherwise it's not logged in, and then I just throw this back as a simple HTTP response. This isn't all that useful. It's just showing you how to get your hands on those values if you're in Python. So sometimes you're in Python, sometimes you're in templates. Quite commonly you're in templates. So I've been talking about a view that requires a logged in user. And so again, imagine something where you're sort of reading your messages on an online system, and you bookmark the message reading URL, and then you shut your browser down, which logs you out of the system, and then you click on that bookmark straight to the messages, my inbox or whatever, and then inbox looks at you and says, you're not logged in. So I got to send you to log in, you finish logging in, and then you come back. That's what the next equals does. Now there's a couple of ways in views to write that kind of feature that basically says, this view is fine, but only fine for logged in users. So let's take a look. So one of them is checking to see if user is authenticated. So I have two views in here. One is, I'm going to protect it manually, and that's so you can see how it works, but it's really not the right way to do it. I mean, you can do it this way, but it's like, there's always a better way in Django, always a better way in Django. So here we have a class-based view, and we ask, is the user authenticated? If the user is authenticated, we just do whatever. Now, there might be a whole bunch of stuff in here. There might be a whole bunch of, but I'm just going to render the thing so that's a view. So I'm protecting this particular manual protect view. But if you're authenticated, you can see it, right? It doesn't do anything in particular other than dump a bunch of data out. If you're not authenticated, then I'm going to construct a login URL by calling reverse, say look up the URL for login, add a question mark, and then add the request path, which means wherever we're at, come back to it. So that's the next, and that's going to put next equals, blah, 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 blah. And then instead of returning a render, we return a redirect and say, okay, go to the login URL. So the way this is going to work is, it's going to come in once, right? You're not logged in, so it's redirecting. It's going to go out, but then it's going to come in back again, and this time the user is redirected in, so it's going to show you the page. So you end up going through this twice. Now, that's the bad way to do it, or the wordy way to do it. I mean, it's only 5 lines of code, but I don't like 5 lines of code. So there's this thing called a mixin, and a mixin is a class. The idea of a mixin is that, you know, we have kind of an inherited class. We inherit things that are like just a feature almost. So what we're doing is we're going to take our protect view. It really extends a view, but it's going to also add the capabilities of login required mixin. So login required mixin basically says to Django, if this is here, hey, I want to do this. Don't let the user into this particular view. Protect the view. So this is another protected view, but by simply including this little signal that says login required mixin, I've mixed this into my view, then it does all this work for us. So what'll happen is it won't even come in, right? It won't even come in if the user's not logged in. It will redirect and then come back and then let this code in the get run only when the user's logged in. And so this is by far the most common way to do it, is just called login required mixin, saving you from writing all these lines of code, right? So all these extra things, because do I remember how to do this? What if I write that 5,000 times in an application? It's really kind of silly when we've got login required mixin that takes care of all this stuff. And just to review, this is what that view looks like. It just sort of dumps all that stuff out. I use the same I use the same template for all of these views. So login, like many things in Django, is simple. It's easy. You add the things to installed apps and URL patterns. You make yourself a template. I didn't go into great detail. Django has great documentation if you want to get really sophisticated. What I tend to do is I get 1 or 2 templates working for login. I'm like, I want to use this one today or that one. So this is where like the sample code has 2 different logins that we're going to use. One is a simple local login, and the other one actually is a login when we're going to use GitHub to do our logins. You can get yourself you get your URLs for login with reverse lazy, or the URL template tag. And then if we want to come back, we add an X parameter to those URLs. And then when we have a view and we say, look, this view is going to depend on request.user or the user in the user template tag, just add login required mixin, and then Django takes care of making sure that You can't get to the view unless you're logged in, and if you try to get to the view, it tries to let you log in, and if you are login successful, you come back to the view, and it's all transparent to you, and it's literally just one little comma thing in the create. Hello, and welcome to our lecture on forms. There's actually quite a few lectures here because we're going to talk about how forms work in HTML and HTTP, and then we're going to talk about how they work in Django. So forms are the way that we put HTML in browsers that have fill-in-the-blank areas. And so the idea is that you draw some fields and some places for the user to type, and then you have some way of sending the data up to the server. And so we'll take a look at a number of different ways to gather this stuff up and send it to a server. There are two basic ways to talk to the server with form data. Everything we've been doing when you do an anchor tag is a GET request, which means you're going to get a document and show it. And you can put parameters on the end of those, like the question mark guess equals 42. You can put that on the end of a URL. But then what we're going to really introduce and talk more about is the notion of posting data. So in forms, you can actually do getting or posting. And so let's take a look at some code here. So this is a little bit of utility code that I'm going to use over and over and over again because the get data and the post data and even the cookie data and stuff come in as dictionaries. They look like dictionaries, key value pairs. And so I just wanted a way to dump the data. I want a little label, probably should call that guy label, and then a dictionary. And so I'm just going to retrieve, go through all the items and call HTML escape so that we just don't end up with HTML cross-site scripting injection. Just print the keys and values out and put some paragraph tags and stuff like that. So it's just a way to dump this out so I can show it to you and not put this code on every one of my slides. So just remember that that's what dump data does. And here is a little form that prints out a form and then retrieves the form. So you'll note the dump data. If there is no data in request.get, it doesn't print anything out. But this ends up producing a form, right? And there's a form tag, there's an input tag. Input is the painting. Just put some text out, and then this label, this box here, is the input type equals text, name equals guess, size equals 40, and then we put a submit button out. And we can type some stuff in, and we can hit the submit button, type 42 in, and hit submit button. And you will notice that once this submit button is hit, it adds automatically onto the end of the URL that it came from, guess equals 42. And then it sends that back and does another GET request, but this time it does a GET request with equals 42. In comes this guess equals 42 is put onto the request.get, and then we dump it out so we get to see the key value pair of guess equals 42. And again, Django's taking care of all that parsing and everything before we get to it. Now, this is pretty much the exact same thing. Later we're going to talk about this CSRF exempt. This is to keep it as simple as possible for now. And all we have to do is tell that we would like to communicate this same form of data, one input field and a submit button. We're going to communicate this from the browser to the server using the post method. And so this is a communication to the browser when the server says, I would like to send this data using the technique of post, not the technique of get. And so, it prints out, we put in the number, we submit it, and so the first thing that you'll notice is there's no key value pairs, and that's because the post actually transports the data to the server in a different way. And it appears in a different key value pair. We can tell whether it's a post or a get, and if it's a get, we get our get parameters in request.get, and if it's a post, we get our post parameters in request.post. And so we still get the same guess keyword equals the number 42, okay? And so that's simply the two ways of transporting it. And this is talking about those two ways, right? The browser has a form, blah, 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 input type equals guess, and the name field, name equals guess, is the field that is going to tell what the key value pair is. So if you're going to put a post, you're going to hit the submit button on a get form, it does a get to wherever it came from, right? And then appends the key value pair to the end. And again, that goes into Django, which parses it and puts it in request.get, etc., etc., etc. And if all you do is you tell it with a method equals post, then it chooses a different way. So the post is going to the same URL, but there are no parameters here. And so there's a series of headers like, you know, what is my preferred language, et cetera, what I'm using for my browser, the content type, is this application URL form encoded, and that's talking about this. Now remember, this is going into the server, so the content type coming out tells if it's an HTML page or a JPEG, but the content type going in tells the browser, tells the server how to parse this. So it leaves a blank line, it's very symmetric with how the server sends us pages back, and then guess equals 42. Now, there's some complexity here, and there's some complexity in that post data, and there is some complexity in the get parameters where if you're sending special characters, there's ways they have to be encoded, but we're going to ignore that for now. Just understand that the reason you don't see the parameters on the post request is the data has been transported as part of the HTTP connection, and it's later on in the connection after all the headers have been sent. So you might say it doesn't matter. Well, it does matter. So there's a couple of simple rules. The post needs to be used when data is going to be created or modified, and we'll see situations where we force this, where you don't want to delete something on a GET request. If you're reading or searching, GET is great. It should never be used to insert, modify, or delete data, anything that's going to change the state of the system. And part of the problem is that web spiders will find GET requests. So you might, if you build a bad application and like a catalog of bearings, for example, and you have a delete that happens to be a GET request, and a web spider grabs your page and hits all those URLs, you might find that the web spider just wiped out your database. So web spiders do not follow posts because they assume that by following posts they might be changing your data, but by following gets, they're just reading your data, and that's all a web spider really wants to do, unless of course it's doing some kind of automation. So get URLs are supposed to be idempotent. So the idea is if you say blah 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 guess equals 42, it's supposed to kind of give you back the same page. Now that's like saying you know, blah 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 current calendar. Well, what is the current calendar? It might be, it's not identical, but it is sort of semantically the same thing. So you're supposed to be able to go bookmark a GET. You know, you can bookmark a GET URL, but not like you might say, where's my inbox? You know, here's a URL to my inbox in some kind of a system to read my data. And so you can bookmark that and go back to your inbox. It should be a GET request. You shouldn't be bookmarking posters. The other thing is that depending on your browser, your web server software, etc., you may have an upper limit on the GET. Let's just think 2,000 characters. Doesn't mean you should worry about it too much, but just large things, especially when we start uploading files like pictures, then all of a sudden the GET is impossible and you have to use post. So now we're going to do a real simple run through of the kinds of things that you can do in HTML and forms. This is only the beginning, and there's so many great online resources for how to do forms in HTML. So I've already showed you the basic text field. We'll talk about the password field, radio button, checkbox, select, and drop down. And I just got kind of this one HTML page that you can view the source of and borrow. I kind of write this stuff up for me for a quick reference. So we've already talked about the text field, right? So input type equals text, and then the name is the value. The ID, don't get too stuck on the ID. The ID has to do with how you associate the label tag with the field, and so that knows that somehow account and this text box are connected. So the ID is more of a browser thing, and the name equals is the thing that it's going to be sent to the browser. So the browser is always going to get key value pairs. And so, you know, when we type Beth and we hit submit, then we're going to get the incoming post data is going to have the value account equals Beth. Now, if you look at password, that's a type. Password, for all intents and purposes, is a text type, and it shows it so people can't shoulder surf and see what it is. Of course, they can watch you type your password, but it shows asterisks in the box while you're typing. But then it's important to realize that once the data is submitted, the data is submitted in plain text. And so here's another one, another nickname. So Nick equals NICK. So that's basically the variance of the input types of text. Hidden, type equals hidden is another one where you just don't see it in the user interface. We're going to use one of those input type equals hidden in a bit. A radio button is designed for situations where you can only pick one of two things. So when you hit AM, the PM goes off. When you hit PM, the AM goes off. And you can actually have a whole bunch of them, and you can click them. Now they're drawn together because they're type equals radio, and then the name is identical. And interestingly, you can scatter these literally all over the page. It doesn't lead to very good user interface, but away you go. And so what happens is again, no matter how many of these you put with a name equals when, no matter where you put them on the page, if you click one, all the others are going to turn off. And so the one that's clicked, they all have different values. And so what will happen is whatever one is clicked at the moment that you actually send it, that will be the key value pair, where when equals PM, because only one can be selected, and it's up to you to make these things unique. Or maybe you don't want them unique. You do whatever you want. And so in this case, the PM one is selected, so we see when equals PM in the incoming post data. So that's a radio button. So this is a checkbox. This is probably more useful in many ways. Checkboxes, you can have as many that you want, and each of them are individual and distinct. So if you take a look, for example, you see that you have different names: class 1, class 2, and class 3, right? So that each checkbox has its own name, but the checkboxes are actually just little checkboxes. The text here is just text. The text is not really a critical part of it. The value is what will get sent if that checkbox is checked. And so in this example, we've checked Pi free and SI 539, and you'll notice that two of them have values and one of them doesn't. Now the key is often you're just checking to see if the data is there. In this case, class 3 is not in the post data, and class 1 is on. That's the default. If you don't say value equals, it's like value equals on, or whatever the value is that you put in that checkbox. And so you get to decide these. You might easily think that you don't need any values whatsoever because you're really looking for the name of the field, and you want the name of the field to be distinct. And so again, you can check as many of the checkboxes as you want. You can uncheck them, you can check none of them, and you can check all of them. So those are checkboxes. So to describe a drop-down is a multiple choice option basically for a single value that's going to be sent back to you. And so we have a select, which is the whole thing, and that gives the name, the keyword that it's going to be sent back to. And then we have a series of options, and you'll notice there's no value on the select, but each option has its own value, right? So I happen to be going 0, 1, 2, and these are strings, not numbers. They often are just numbers to make our lives simple. And then you have some text, etc., etc., etc. And so you pick one. In this case, I leave it default, and I hit the submit. So soda is going to be equal to 0. So this happened to be the one that's selected when we hit submit. Okay? So that's what a select looks like. You can also make a select that has some defaulted one, and so you just put selected on one of them. So that means it's the drop down. They're all there, right? They're all there. If you click on this thing, you'll see, if you click on which snack, you're going to see all the different snacks. Peanuts is pre-selected. And if I don't change it and hit submit, then we're going to see snack equals the value, which is peanuts. So that's an example that you don't have to make numbers, although it's really common to be using numbers. So that's a drop down with a default other than the first item. The default is it's the first item unless you do it otherwise. When you're typing in comments or a blog post, a big long blob of text, you use a text area tag. The text area tag is a little bit different in that it doesn't have a value equals. It does have a name equals. It has rows and columns to tell how tall it is and how wide it is. There are clever styling libraries that make these a little prettier. But basically what it is, it's a series of text, including paragraphs, including new lines, etc. And you're just allowed to type with new lines and edit and cursor around in here and build all kind of stuff. And then you send it in, and you can put default text in here. You can edit the text, you can change it, and it comes in as a key value pair with new lines and everything and any weird spacing that you might put in. But it's basically a block of text, like a comment or like a comment or a blog post or something like that. So the last thing on this page here is the submit button. And so you can make a type equals submit, and you can give it a name, and again that's a key value pair, and a value. Now the submit is a little bit weird in that the value actually appears on the submit. What we tend to do is this submit, and if you're in a multi-language environment, you're going to want that to be whatever language of the user. So usually what we do is I carefully name the variables, or the name of the form, and then I check for this to exist. And if I have a bunch of buttons, I name them differently and don't really actually look at this text, because that text might want to be translated at some point in time. So that's an input type. Input type equals button. This is a little pattern where I'm going to do like an escape or a back or something like that. And then sometimes it's easier just to do a little JavaScript. And what this little JavaScript chunk is, location.href equals quote www.djfree.com return false. What this says is it actually sort of, when you press this escape button, it goes up in the browser and in effect pastes this little URL into the URL bar and then hits enter, and return false keeps the form from being submitted. And so this is a way that I often will put a simple cancel or escape or something else in a form. Just if I know the URL I want to go back to or go to, then you can put it in here and click location.href. So those are the input types that have been around for probably 20 years. Yeah, at least 20, 25 years. HTML5 is a more recent phenomenon, although by now it's pretty well supported in most browsers. Defined a whole new set of input types. And what's nice about this is we were slowly but surely building complex libraries to solve all these problems. But now we can use these input types, and now each browser can support them to their own way. And they all fall back to type equals text. And so if you have a really old browser, these don't cause trouble. So here's just some samples of some things. So type equals color is a color picker, and that's going to pop up a color picker, let you cruise around. That color picker is defined by the browser and usually the operating system, and so you'll pick a color, and then that color is going to go in hex format, and that's the red, the green, and the blue. And so that's what colors look like. You can have type equals date, and so here's a date, and they pop in here. You're going to pop up a date picker for the birthday. You'll pop up a date picker, and you'll be able to kind of move around and pick a date, and then that'll put that date in as a string. They're all going to turn into strings when they're being sent in. A couple of the other ones, like email, name equals email, that basically does validation that says it's got to have an @ sign. There's some rules about what is and isn't a valid email. And so this will refuse to submit this form unless there's a valid email in there. The same is true for number. If you put something that's like 25 and it's not between 1 and 5 with min and max here, we're going to refuse to submit the form. The same is true for a type equals URL. It's really a validation on the form to say, look, you can't put something in here that's not a valid URL. And just to prove that it doesn't matter, if you make any type, which flying doesn't exist, you can type something in and it just functions as a text field. And so in a way, all these fall back to text fields. Now the key thing is when you hit the submit button, normally that gathers up the form and sends it to the server. But when you use this HTML5 validation like date, number, email, URL, it actually will, before you hit the submit button, before it actually sends it, it's going to do a quick validation on these things, and it will actually stop and say, you know what, you didn't get that one right, and it just refuses to submit. So you can't override that in your application. What happens is the data doesn't get submitted at all so the browser blocks the submission of the data. Now if it's not an HTML5 browser, it's going to get submitted with no validation whatsoever. So we still have to kind of check this data for sanity, which we'll talk about soon about how to do that in the server. But this is quite nice because it gives your user some immediate feedback, kind of customized to the browser, so the browser takes some responsibility for helping get the user to type the right stuff in. Now that we've talked about forms a bit, I want to talk a little bit about security in forms. I want to talk about a security issue called cross-site request forgery, or CSRF. So the idea of a CSRF attack is that a rogue site it has to do with cookies and how cookies get sent to sites. So let's say you're logged into my site, and a rogue site generates a page that's going to post. And on every form you can post to a site other than the one it came from. And so if I can get data that I want to send to the legitimate server, the rogue site can set up a post, and then if I can convince you to hit the button, then it will grab the cookie and send it to the legitimate server that you're already logged into and perhaps do something dangerous. And so the rogue server doesn't need to know the cookie. The rogue server just needs to convince you to click on a rogue form to send to the request server. So the defense for CSRF is don't be confused with session. It is going to use session. We're going to grab another large random number, and we're going to call it the CSRF token, and we're going to stick that in the session. And then what we do is every time we send a form out that's coming from our server, we add a little input hidden tag that has this CSRF token. And then when the post comes in, we check the CSRF token that's coming in the post data, and then we check it against the one that's in the session, and then rejects it if it doesn't match. So here's a picture of how this works, right? So we'll have a legitimate server, right? We're going to produce a page by the legitimate server, and it's going to post back to this same server. The action is the URL to send the post data to, and we got some key value pairs and a submit button, right? So you hit the submit button, and it's going to come back to the server. Now, one of the things that the browser is supposed to do is pull the cookies for that server and send it. So it sends it both a post and the data, but it also sends the session ID cookie. And then what happens is that the Django gets its hands on it. It looks up the session ID, pulls it in, and notices that it's C7 and I've been logged as an instructor, and then I can actually change this grade and set the grade, and it works. Okay. Now, here is what happens when you get to a CSRF attack. So somehow a page gets sent to the server, right? Sent from a rogue server, and it just has this form: method equals post, action equals DJ. It's not the action; it's going to a different place, and it puts sort of a new grade and then a submit. So what happens is this submit comes in, and the browser dutifully appends the cookie to it, and it sends it. Now, you had to be tricked into getting to this page and sometimes tricked into submitting the page. But once the post comes in, it has the legit cookie in it. The cookie is used to look up the session and reassociate it, and we can check in the session that the user is indeed logged in, and we'll let the thing set the grade to 1.0. So this would be a way, if you could convince a logged in instructor to run a post form that you created, you could basically change your grades. So that's how it works. That's how a CSRF attack. You have to be tricked twice first, but there's ways in JavaScript to make it so it's hardly noticeable that you get tricked. So if you do this with CSRF, the legit server basically adds another value, not the session ID, but another value in the session, which is a large randomly chosen number. And then when a page comes out, it's a legit page, and it uses a type hidden variable and puts the CSRF value in. Now you hit the submit button, and the CSRF is coming in as post data. Your regular data, the grade data, is coming in, and the browser dutifully appends the session. And so then using the session cookie, it reassociates the session, says, yep, you're C7, you're the instructor, and the CSRF works, CSRF matches, so let's go ahead and let you set the grade. So we let them in. With the attack blocked, because the rogue server can generate a page, but it doesn't know what the CSRF is. So it could, who knows what the CSRF is, so it generates it. Maybe it can put a CSRF, but it doesn't know it. So then the post happens, and all the data gets gathered up, and so it sends the CSRF, but it's not the right CSRF. The session ID is sent in, and so the session is pulled in. We know it's user C7, we know it's instructor, but we're going to check to see if the CSRF matches, and then it blows up. And so then you just refuse the post, probably log the user out, and then log some kind of a security error. So the idea is by having this little CSRF number in the session, we can then take care of that. So like most things, Django comes out of the box with CSRF protection built in. Just like the session, we've got CSRF middleware just dropped in. And actually it works automatically. You don't even have to ask for it to work. Once you have a session, it starts putting out CSRF things.